Welcome to Homework Lib.
Hi, so over here we're told that we need to write down the thermochemical equation for the combustion of butane. Over here we're told that the heat that is going to be released for this combustion reaction is 22,874 kilojoules of heat per mole of butane gas. So first of all, we need to write down the balanced chemical reaction. C4H10 plus oxygen is going to produce CO2 plus water. In this case, the number of carbon atoms is going to be balanced over here with a 4. The hydrogens, we are going to require a factor of 5 over here to account for all of the hydrogens. And finally, we just balance out the oxygens with the oxygen on the reaction. So we have 8 oxygens plus 5. This is uh, this is 13, so we're going to have 13 halves of CO2. So now that we have the fully balanced chemical reaction, what we want to know is to calculate the mass. Oh, of course, over here, the delta H of the reaction corresponds to 2,874 kilojoules. That is going to be released, so the delta H is going to be negative. This is going to be an exothermic reaction, right? So now, we want to calculate the mass of butane that must be burned in order to increase the temperature by 1.56 degrees Celsius of 1,000 grams of water. So first of all, the heat capacity of water is going to be equal to 4.8184 joules per gram degree Celsius. Let me check up the value just again. Yes. And additionally to that, we know that the heat capacity of the calorimeter is going to be equal to 958 joules per degree Celsius directly. And we want to achieve a change of temperature equal to 1.56 degrees Celsius. So over here, what we know is that the heat required for this is going to be equal to 1,000 grams of, well, let me write down the formula, sorry about that. Mass of water times heat capacity of water times the delta T plus the heat capacity of the calorimeter times the delta T for the calorimeter, which is going to be the same value for delta T. So this becomes 1,000 grams multiplied by 4.184 joule per gram degree Celsius multiplied by 1.56 degrees Celsius plus 958 joules times 1.56. So the amount of heat required is going to be equal to 8,021.52 joules of energy required, which is the same as 8.02152 kilojoules. So now the only thing that we need to do is to know the mass of butane that we are going to require. The information is C4H10 is going to have a molecular weight equal to 58.12 grams per mole. This is going to be the molecular weight of butane. And we're going to use this as part of our information. So we're going to require 8.02 152 kilojoules in order to increase the temperature of water by this amount. We're told that 2,874 kilojoules are going to be given by 1 mole of combustion of butane of C4H10. And finally, we know that 1 mole of C4H10 is going to have a mass corresponding to the molecular weight, 58.12. Thus, the mass required is going to be 0.1622167 grams of C4H10. So over here, I'm plugging in the value with all the significant figures from my calculator, so you can cut it out to the appropriate number required by your professor or the platform that you're employing. Over here, in principle, it should be given up to 3 significant digits since the number with the lowest amount of significant figures is going to be the 1.56 degrees Celsius coming over there. So it should be 0.162 grams of the 3 significant figures. But if your professor requires more or less, you can cut up the value that I gave over here. And with that, it would be all. Thank you very much and have a good one.